SpagoBI and Big Data, a smart approach to turn data into knowledge. My name is Monica Franceschini and I'm IT Solution Architect for the SpagoBI Competency Center of the Engineering Group. And today I'm going to introduce you to this theme, which is very hot at the moment, and SpagoBI is approaching big data in many different ways. So first of all, a few words about the title of this webinar, so smart approach. So why we call it smart approach? First of all, because we are facing both the information building scenario and also the visualization theme. So about the information building, we are managing information building through the approach to different data sources with many different connections depending on the data source. And we will see later on the slides how we can manage this situation. Then we have the concept of dataset, which is, let's say, the item, the issue that stores the result set of an inquiry towards these different data sources. Then we have another tool which is very important and allows the end user or the power user to perform its own queries on different sources, on different databases. And it is the self-service BI tool, which, if you know SpagoBI already, is called Query by Example Engine, QBE. And then we also have another instrument, which is the Agile development of information, which is, let's say, a life cycle of information, which is built with the self-service BI and then managed through the worksheet engine. After all, we have also the visualization, which can be brought in a very nice way with the dashboard engines, the dashboard documents, which allows the interactions between documents, different documents interacting one with each other. And then the behavioral model, which is leading the document's behavior, which can be applied also to the visualizations allowed for the big data items and to the big data, let's say. And then we have the ad hoc reporting, which is our worksheet engine, which allows the end user to create and manage its own charts depending on the data set he chooses. So smart approach for us means a comprehensive approach. With the comprehensive approach, we mean both the information building point of view and the visualization point of view, but also the different kind of visualization and the different kind of approach to the data. Okay, here we are. So comprehensive approach, as you see here, we have SpagoBI for Big Data, which allows the developers to face and to interact with big data sets coming from the Hadoop ecosystem, NoSQL databases, and so on, but also streams of data, byte streams on data in motion data, let's say, data on the fly, and last but not least, the semantic information, which are often stored in graph databases or semantic RDF databases. Then SpagoBI allows a different kind of analytics. You already know maybe that SpagoBI is integrates altogether different kind of engines for different kind of charts, or different kind of visualizations and analytics, of course. So this is, well, quite, it involves different kind of analytics. You can think about static reports, but also geographical documents or charts, and also some kind of let's say handmade by the end user documents, just like it is the worksheet engine. Okay, and now we see that the comprehensive approach also means that we start from the building of information facing NoSQL databases, the Hadoop ecosystem with all of its projects. So it's NoSQL databases, you can think of HBase or Ivy, but also Impala for Cloudera distribution, and then the real-time data, so what we call the data on the fly, and also the self-service, which is another source of information. And then through the concept of dataset, which is the repository of information where the result set of the query is stored, and we can see different kind of visualizations. And as I said before, you can produce static reports with our engines like BERT or Jasper, the engines that we integrate in SpagoBI, and then charts with XJS or HighCharts and so on, and also our own geographical reporting engine and the ad hoc reporting through the worksheet. So we have three scenarios. You see in the middle of the picture the dataset component, this one, which is an independent component, which can manage connection towards different kind of sources. And you see here we have three different scenarios. There were three scenarios we were talking in the slides before. So the data sources. Right now we have developed the interaction towards Hive, Cassandra, and HBase, which are the most, let's say, common ways for a BI tool to access information stored in Hadoop. You see here all of these three projects are NoSQL databases, but also of the belonging to the Hadoop ecosystem. And then we have developed a solution over stream processors and complex event processors managing streams of data. And we have also managed the interaction and let's say the collection of data from semantic databases, so graph databases. You see here some names. So you have OrientDB, which is an Italian product, but also the Neo technologies, and we have, for example, Neo4j graph database with its semantic plugin. And the dataset is in the middle of the picture, and you see here that it allows the developers to create their own visualization over the data collected by the dataset. So the dataset aggregates the information from these different kind of sources. So the dataset component, here we focus over this component. If you are familiar to SpagoBI, you may already know what is the meaning of this component. Well, it's getting even more powerful with the big data solution, because nowadays it allows different kind of behaviors. So not only the behavioral model, which can be applied, which can still be applied to the dataset. So analytical drivers, as we call the parameters, let's say, or the list of values, so the love items, can be applied to the dataset, but also, let's say, the user attributes, the user profile attributes that can slightly change the behavior of a dataset. So it can influence the query and what the data that it's extracted from the data sources. So this way you can parameterize you can put parameters in the dataset to change its behavior and the data, the result set, let's say, of the dataset. But this object also can be scheduled, because the schedulation of the dataset can be a solution. So the developer can schedule, as you schedule nowadays the documents, you can schedule the dataset at different times, maybe in the night, to produce the result set over which documents can take data and produce their own results. So this is a solution, and the dataset can be stored in different ways. So in persistent storages, just like traditional databases, but also the NoSQL databases of the Hadoop ecosystem, and also in some in-memory supports. And then, as you see here, of course, dataset is the main object, which nowadays we have integrated also in the static reports. So I mean that also BERT reports can use a SpagoBI dataset to produce their visualization. The dataset nowadays can be used directly by the query by example engine, and I don't know if you already, if you are familiar to the query by example engine. It's our self-service tool. So regarding the first scenarios, so the big data storages, here we have a slide that summarizes the informations about dataset towards this kind of data sources. Here you see that the dataset is mainly a query, an interrogation, an inquiry over this kind of data sources, which are nowadays are HBase, which is the column family NoSQL database of Hadoop, and then we have Cassandra, which is another column family NoSQL database of the Apache. Apache group. And then we have Ivy, which is the data warehouse of Hadoop, which stores, let's say, that stores the files. I know that you already know, but stores the files in the form of tables. So you can query Hive, HBase, Cassandra, but you can also use Impala as a query accelerator, a query engine towards Hive. Through some different SQL-like languages. We have HBQL for HBase, CQL for Cassandra, IVQL towards Hive, and then of course the Impala language, which is a little bit different from the Hive query language, but most of all it's the same. And we use this different kind of languages to query data on this to query these databases, and we connect to these databases with their JDBC drivers. So each of them provides a JDBC driver, which can be used with a JDBC connection or a JNDI connection as usual, stored in, let's say, the server XML file of the Tomcat, of your Tomcat. So it's a resource for SpagoBI. And you can query them and produce, of course, the dataset result set, which, as we said before, can be persisted or it can be scheduled, and you can produce, of course, an aggregation of the informations. So the main concept is that to produce a BI document, you need to create, to ask for data, aggregated data, let's say. So maybe you can run a query which takes lot of time, but at the end the result is maybe 3 lines of a table, let's say 3 rows of a result set. So and it can be stored wherever you want. It just takes much time to produce it, but then if you have to produce, let's say, a pie chart, you just need the end result, and the result set of this data set can be stored whenever and in whatever place you like. So also in a traditional database if the format is permits it. Moreover, of course, as we said before, you can use the behavioral model applied to the data set. Of course, in this case, you cannot persist it, so it's up to the developer to understand whether it's possible to persist it or not. Anyway, it's an option. If you don't choose parameters, you can persist it, of course. Otherwise, it's not the good choice, the best choice. Now we try to go on. Okay, and now we're going to see the second scenario, which involves, as we were talking before, which involves, of course, the emotion data, so the real-time scenario. As you see here, we have approached Storm. Storm is a stream processor which takes each tuple of the coming from a source of information. You can think of Twitter, which is Storm is belongs to Twitter, let's say, but it is an open source project, and you can say that Storm takes each tuple coming from this information producer and makes some processes over these informations. So the output is are streams of bytes, and of course you need some component which at the end of this process to notify the newly available data to SpagoBI, and this component is the SpagoBI adapter, which chooses different kind of channels, web services, Java API, queues, and so on, to notify the event dispatcher object, which is another object of the SpagoBI server, that there are new data available for the dataset. So the event dispatcher could also try to put this data to different handlers, so SMS, alerts, emails, but in this case the best choice, of course, is the dataset handler, which will take the output of the data streaming and possibly with a time window. So the dataset will be notified after a sliding time window of the newly available data. Of course, we could also apply this behavior to complex event processors, which are another kind of tools to manage emotion data. The complex event processor already have the time window paradigm inside them. So they already behave in this way, and each data, every data are different kind of events for them. So the event handler dataset, which is always a dataset, can store the informations, the result set, on any memory support, which can be used to by the visualization output of SpagoBI server to produce the result. Of course, in this case, the persistency in physical storage is less important. It's not so useful. We use in-memory support for this kind of behavior, so to face the real-time data. Now we're going to see another kind of the third scenario. The third scenario involves, in this case, the semantic data. Sorry about the latency of the slides, but it happens like this today. And some words before the slide. When you think about big data, you also have to think about classifying the data, and most of the time you need to classify. You can classify data using the RDF semantic notation, or also you can link data together, and you can talk in this case about linked data. So you produce additional information regarding the data you are going to face, because you add also the relationships between the data, the single items of the single entities, as they call them. So in this case, the slide doesn't move, okay. Oh. Well, in this case, we need to store this related information in other kind of storages. As all of you know, maybe there are many kind of graph databases with semantic extensions or not that can manage this kind of information. Sorry, I have to do something. Okay, and of course, many of them provide also some kind of JDBC drivers. We tried, and we can connect to Neo4j, for example. Neo4j offers a JDBC driver which is quite mature, but also OrientDB offers a JDBC driver for SpagoBI to create a connection treating the graph database as just like a simple database, let's say. Then we have the tool to visualize. Okay, here it is, the slide finally. Okay, so here we have this kind of network. You see, this is a representation of a network that SpagoBI can, of course, can produce through the newly available tool, which is the Network Analysis Engine, and it's developed over the Cytoscape project, open source project. So you can produce networks documents, and you can extract data from these kind of graph databases, okay, where you can store each groups of information, and you can classify data you have on your Hadoop, for example, on your Hadoop. And this is quite useful because you can use the network analysis engine you see here as a kind of analytical driver. So here you have in this slide, you see the semantic database, which is a kind of data source, so through a connection, and the query made with different kind of languages. All of them are SQL-like languages, but you can also have Gremlin, Sparkle, and Cypher for Neo4j, for example. And you can have, in any case, some high-level languages, SQL-like high-level languages that you can use in your data set to produce the network analysis engine, to document, sorry, through the network analysis engine. So this is a kind of network. You see here, when you have all the classification you have made over the data you have stored in your Hadoop. And you can click over the nodes, so the vertex or the edges of the graph, and you can filter data that are stored in your Hadoop or in your NoSQL databases, anyway, your big data, let's say. And then finally you can produce your visualization in a way that allows, in a filtered way, let's say. So the network analysis can behave just like an analytical driver, let's say a parameter, because we in our behavioral model we call analytical driver the parameters. And so the semantic is important, and because you may have many data, but it's important also to classify them, to store them in a and categorize them, and to store them maybe with annotations and giving them an additional information that maybe you don't have at the beginning. So it's not maybe just a problem of MapReduce to create data sets. Maybe you can add something more through the semantic annotations. Let's see if we can move on. Okay, so now a few words about we come back at the comprehensive approach, let's say comprehensive approach meaning. So what we mean by comprehensive approach. So we saw that we have different kind of data sources, different kind of inputs for our visualization, for our business intelligence analytics. And here you see that we also have different ways to produce this result. You see here that now we have arrows in different directions. So from the information building to visualization, but also from visualization to information building. And how is it made? It is made through the dataset component linking together the ad hoc reporting and the self-service BI. So what do we mean? We mean that the users, let's say power users, but also the end users, can approach data and visualize what is maybe the results, visualize the result of a data set through charts or through tables and so on, but maybe they are not satisfied at all, so they want to slightly modify the input data they are using for their representation, and so they want to go back to the information building, and they can make it through an agile development of information. This agile development of information can be reached through the life cycle of the information, linking together ad hoc reporting and self-service BI. So the worksheet and the query by example engine are working together, using a data set as the input, the starting point, and producing at the end more information, more knowledge. So I'm always facing the problem of the slide, okay, here. And you see here this, this drawing shows how to start from big data storages. Here you can produce a data set that can be stored in persistent storages or in memory supports, and then it can be used by the worksheet engine to create charts. Okay, this is a query. You can create charts over this query result set. And then here, maybe you are not satisfied, you want to refine the query, then you can access the query by example, through the query by example engine, you can access the dataset itself once again, and you can maybe persist it once again to make it available as a new dataset, or you can create a new query, and so a new dataset, and you can persist the result set. So you can go on switching from one tool to the other to create information, to create a new knowledge, let's say, for the user, which will understand better the data that he is watching. And this is also much powerful for people who wants to cover the role of the data scientist, let's say, because they can understand better the data they are seeing, they can refine their own queries, and they can understand better and produce also the proper visualization for the data they are looking at. So this is a screenshot about our self-service tool, which is the query by example. You can see here that this is the interface of SpagoBI 4, and nowadays we are moving on, so we are always adding new features to this two tools, so the worksheet and the query by example engine. They are working together very closely, and but they can also work in a standalone mode, one for itself. So through the self-service engine, you can take a data set. Once upon a time, you just could open data marts and in SpagoBI, and they were, let's say, a portion, a model over a data warehouse. Nowadays, they are a data set. So you can produce a data set over Ivy, let's say, and you can open it with the query by example engine. So here you see that you can create new data sets in a graphical and smart way. You can define your own queries over the data set, so you can produce, you can use the data set, so a query, and you can refine it, producing a query over the query you already made, and then save it and create a new data set, so a new input source, new data source. And you can refine, of course, your analysis. So this is a slide about the ad hoc reporting, and our ad hoc reporting tool is the worksheet. Here you see we have two screenshots. Well, this one in the back is the designer of the worksheet. You see here you have all the selected fields of a data set. So what you took as columns from in the select from the data set, from the table or the data set you are looking at, and what you extract, let's say. And then you have different ways to visualize the result set. Okay, the worksheet works over a result set, which is stored in the dataset object. So you can interact with the query by example to refresh the data. So you can apply the worksheet on different query by example engines, so over different query by example documents, let's say. And you can create your prototype for your project. The prototype means that this is not the final documents you are going to release to your customer, but you just want to prepare and you want to analyze data and maybe think about what is the best way to present your queries, your analysis, okay? And so you can provide here in this screenshot, which is the nearest one, this one above, you can see that you can provide an instant graphical meaning to your data set. So you can just produce, you can understand better your data, producing different kind of charts, and you can choose between the one that suits better, and if it doesn't suit, you can come back to the query by example engine, refining your query. Then you have the dashboards. The dashboard, maybe you already know because it is an old concept in SpagoBI server. They are the cockpits, so a composition of documents. Each document can work in a standalone mode, but they can also interact one with each other, passing parameter one to each other and passing information, refreshing themselves depending to the behavior of the previous document they are linked to. So you can aggregate, let's say, the analysis to get information at a glance. So you can produce in a single screenshot, you can make available all the informations you have, and you can make them interact one with each other. So they can be also different kind of documents. You don't have to put in the dashboard the same kind of documents, let's say statistical reports in each single space of the window, but you just can put geographical documents interacting with network analysis, and you can have them charts or statistical reports and so on. And you can use each single document to filter data to see the information change in the following reports and documents. So this is a nice way to have information at the first glance. So now what comes next? As you see here, we are facing big data as unstructured and heterogeneous data, and with this kind of tools, we are with these new information building technologies, we want to give a dictionary analysis. So we need to let's say integrate statistical computing, then data mining, maybe with Mahout, text mining, or statistical computing with R, and then sentiment analysis, and then using more advanced and predictive analytics. We want to also to create new kind of visualizations. Okay, it's not just to create the analysis, so to create maybe a wonderful analysis of data, but then you don't know how to represent them. Okay, so this is another challenge for BI tools, because for sure we need new visualization tools, and by now we faced this with this cycle of information through the information building and the visualization cooperating together in the life cycle of the agile development of information. But now we need something more specific for this kind of new representation, also data mining, text mining, and so on. So by now this is all. Where here you see all the information. You can find us on our website, and you can also contact us at SpagoBI@Git. So this is how we face the big data issue.